In this video, we're going to multiply and divide radicals. So the important thing to recognize is that we're going to go ahead and focus the outside numbers together and then the inside numbers together. So we're going to start with the outside. 7 times 2 is 14. And then we're going to multiply the inside numbers together. So 8 times 32 is 256. Now the square root of 256 can be reduced. And if you recognize that 256, the square root of that is actually 16. It's a perfect square. If you didn't recognize it, you could break it down and do a factor tree and break it down. So recognizing that's going to help you, save you some time. So this ends up being just 14 times 16. And so the final answer then is 224. Now another way to do this problem is to not multiply this to get the 256. You could actually keep the numbers as small factors. I'm going to show you how to do that as well. When I see this problem and I do this multiply 8 times 32, I might keep it just as 8 times 32. I recognize now that 8 is a factor of 32. It's 8 times 4, and then I have this other 8 here. So if I'm thinking of this as like doing a factor tree, I already have a pair of 8s. And then the 4 can break down and become 2 times 2. So there is a pair of 2s. And then if I pull those out, the 8 comes out and the 2 go out, and 8 times 2 is 16. And that's one way I could find that 16 in here. Okay, so there are a lot of different methods for breaking down those radicals, and we want you to be familiar with them. Okay, number 2, same thing. We're going to take the outside terms. So the number in front of the second radical sign is just a 1. So it's 1 times 4, which is simply 4. On the inside, 21 times 14. Let me get my calculator to do that. Oh. Sorry, guys. Let me get my calculator so I know what 21 times 14 is. It's a big number, 294. So that becomes the square root of 294. Now, when working with these variables, I have to kind of go back to basics. So think about what we did in Algebra 1. If I had something simple like this, a squared times a cubed, and I put that together, it would be a times a times, and then a times a times a. So how many a's do I have all together? Well, there's 5 of them, so a to the 5th. So what you are recognizing is if I'm multiplying all these bases together, I'm really adding those exponents. So when I look at this, a to the 11th power, and I'm multiplying another a, which is a to the 1st power, I'm really adding those exponents, so it becomes a to the 12th power. And then the b stays as b to the 15. Okay, so the 294. So I want to show you something on the Inspire. If you haven't tried this yet, you might try this on your Inspire. Let's see if you guys can see this here. We can actually factor on the Inspire pretty fast. So what you're going to do is select Menu down here right below that Documents and choose number 2 for number. And then choose number 3 for factor. And then it gives you the word factor with parentheses. And we're going to go ahead and put the 294 in there and hit enter. And what that does is it gives us the factors, the prime factors for the number 294. So it ends up being 2 times 3 times 7 squared, or 7 times 7. So what that means then, when I was doing my reverse division, or upside down division, is I end up with a pair of 7s that go outside, and then the 2 and the 3 get multiplied back together to stay inside. So this 7 is going to get multiplied up here with the 4. Okay. And then I have a to the 12th power. So how many pairs are there? There's 6 pairs. And then I have b to the 15th power. So that's b with 7 pairs and 1 left over. So on the inside of my square root, I still have the 2 times 3 here, which gives me a 6. And I still have 1 more b left over. So my final answer then is going to be 28, a to the 6th, b to the 7th, and then the square root of 6b. And that's the end of that problem. That's everything. Another way I could have done this, instead of getting 294 as my big number, I could have stopped at that 21 and 14. And let me just show you on the side here how I could do that. Similar to what I did over here with the 8 and the 32, I could have had the square root of 21 times 14. And what I do is I recognize that 21 and 14 have a common factor of 7. So this is 3 times 7, and then 14 is 2 times 7. And that gives me a pair of 7s to take out. And then the 3 and the 2 get multiplied back in to give me that 6. So if you didn't have a calculator, you didn't have, or if you got to that 294, it's such a big number, this would be another way to do it, is to recognize that 21 and 14 do have a common factor, which gives me a pair of 7s. Okay, let's look at division now. When we divide, we're going to simplify the outsides just by canceling, and then simplify the insides also by canceling. Ultimately, you can never, ever, 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 ever leave a radical in the denominator. So let's go ahead and do some reducing here. So 10 and 2 have a common factor of 2. 10 divided by 2 is 5. 2 divided by 2 is 1. On the inside, 63 and 7 have a common factor of 7. 63 divided by 7 is 9. 7 divided by 7 is 1. So in the end, what I have left over is a fraction. I have a 5 on the outside. I have a 9 on the inside. And I have nothing left but the 1 on the bottom. And I really don't need that 1, but I'm going to put it there for the moment just to see. Okay, I also know now the square root of 9 is 3. So I can write this as 5 times 3. And again, I don't need the 1 on the denominator, so I'm going to leave it out. And then 5 times 3 is 15. And there's the answer for the first problem. Number 4, same idea. We're going to cancel the outside, 6 and 12. They both divide by 6, so I get 1 and 2. On the inside, 204, I can divide them both by 4. 200 divided by 4 is 50. 4 divided by 4 is 1. So that leaves me with a 1 there. So it's just the square root of 50 on the inside. And then I have the 2, and the 2 is on the outside. So cannot cancel the 50 and the 2, because 50 is on the inside and 2 is on the outside. What I can do, though, is I can simplify the square root of 50. And I have different methods for doing that. So you can use your factor tree, or you can use upside down division, or now you can use that Inspire calculator to get those factors. And when I factor that, I do get 5 radical 2. And then the denominator is still 2. Again, the 2's here do not cancel. The top one is inside the radical. The bottom one's not. And 5 and 2 could cancel if they had a common factor, but they do not. So this here is just your final answer, 5 radical 2 divided by 2. Okay, let's take it down to number 5 now. Number 5 looks like it's already simplified, but the problem is that we have a radical in the denominator. So we're going to do a process called rationalizing. It's a big word, rationalize. And when we rationalize, we're removing the square root or the radical that's in the denominator. So to do that, I'm going to go ahead and multiply the top and the bottom by that radical 6. And when I do this, see what happens here. The square root of 6 times the square root of 6 ends up being the square root of 36. And the square root of 36 is just 6 by itself. So that's actually canceling out the square root for me. And that's what we want to have happen. So the denominator now is just plain old 6. The square root's canceled out. The numerator, the 2 stays where it is. The 5 and the 6 are both insides, so they get multiplied together and become a 30. And the last thing I could possibly do here is reduce the 2 and the 6 and make them 1 and 3. So my final answer is the square root of 30 all over 3. And you cannot cancel those because 30 is on the inside and 3 is not inside a radical, it's on the outside. Okay, last one. So I would simplify as much as possible before doing anything else. So I notice that 24 and 30 have a common factor. They have a common factor of 6. So 24 divided by 6 is 4. 30 divided by 6 is 5. So we're going to go ahead and simplify that. Let's rewrite this. So I have the square root of 4 over 5 times the square root of 5. Okay, I do know what the square root of 4 is. That equals 2 over 5 square roots of 5. Okay, so again, it doesn't look like anything else can simplify here. However, we would never keep a radical in the denominator. So I need to go ahead and rationalize this. So the only piece that I need to get rid of is that radical, so I just need to multiply by radical 5 on the bottom and by radical 5 on the top. So in my numerator, I have 2 radical 5. In the denominator, the whole reason for doing this is to make that radical cancel, so that becomes the square root of 25, which equals just 5. Now, this is a little bit confusing for this problem, but we still have this 5 in the beginning here. That's that coefficient on the outside. And then I have this new 5 that I just found. Let me leave it in blue for you to see that. So that gets multiplied by that outside number. So my final answer for this particular problem is going to be 2 radical 5 all over 25. That's the final answer, 2 radical 5 all over 25. Okay, so always try and reduce first, simplify first before you try and rationalize, but we never, ever, ever leave a radical in the denominator.